Good afternoon, my YouTube viewers. It is Crystal here, and I wanted to make another video for you. This video, I'm going to compare a paired t-test with a two-sample t-test, and I'm going to use the exact same data on the paired t-test that I used for the two-sample t-test, and you're going to see for yourself that the t-statistic is different even though we're using the exact same data. The reason why the t-statistic is different is because in the paired t-test, they compare the means and the standard deviations of each different element in the array, and then in the two-sample statistic, that t-test, two-sample t-test, they compare the means and the variances between the whole of the samples, the two samples. And so that's why the t-statistics are going to be different. But what we're going to do is we're going to go ahead and use a real world example, and I'm going to go over the code with you and show you why it's different. So what we're going to do is we're going to check blood pressure before and after treatment, and we're going to use Google Colab to write the script. So your null hypothesis is no significant difference in the blood pressure after treatment, and then your alternate hypothesis is a significant difference in the blood pressure after treatment. So we're going to import our libraries of NumPy, Pandas, and SciPy. So your NumPy performs your numeric computation, your Panda is going to form your data frame, and your SciPy is going to perform your statistical computations. And then so we're going to do our sample data, which is before treatment is an array of blood pressures, and after treatment is an array of blood pressures as well. And then we're going to create the data frame, and then so we're going to have one column that is before treatment, which is going to be before treatment, and another column that is going to be after treatment, which is after treatment. So we calculate our differences. Differences equals before treatment minus after treatment, and then we calculate the mean of the differences. Mean diff equals NP mean differences. Then we calculate the standard deviation of the differences. STD diff equals NP STD differences, and DDOF equals 1. You're going to calculate the standard error of the mean difference. So standard error equals STD diff over NP square root ln differences. And then we're going to print the standard error, and your standard error is going to be 0.26. Then we're going to calculate our degree of freedom. So DF equals ln differences minus 1. And then we're going to calculate the t-value. And so you're going to have alpha, which is your significance level of 0.05. And so critical t equals stats.t ppf, that's percentage point function, 1 minus alpha divided by 2 and df. And then you're going to print your critical value. So your critical value is 2.36. And then we're going to perform the two-paired t-test. So t-stat equals t-stat p-value equals stats.t-test rel, and it's before treatment and after treatment. And then we print our t-statistic and our p-value, and t-statistic is 6.177, and p-value is 0.0004 or 0.0004. And then we interpret the results. So I interpreted the results on the t-statistic and the p-value. So if t-statistics is greater than critical t, you're going to reject the null hypothesis because there is a significant difference in the blood pressure before and after treatment. So that's what we did. Based upon the t-statistic, the null hypothesis is rejected. And then we went ahead and checked it on the alpha. And if p-value is less than alpha, then you're going to reject the null hypothesis because there is a significant difference in the blood pressure. And you can see that because the alpha was less than 0.05, because the p-value was less than 0.05, the null hypothesis was rejected. So for the t-statistic and the null hypothesis, in both instances, for the t-statistic and the alpha, in both instances, the null hypothesis was rejected. So now what we're going to do is we're going to use the exact same data, but we're going to use it for a two-sample t-test instead of a paired t-test. So we're going to calculate everything. And so we got the same data and the same data frame, the same differences, the same mean of the differences, the same STD, standard deviation, the same standard error. The critical t-value is the same, I believe. Let's see what we've got for critical t. Critical t-value is 2.36, and up here it's 2.36. So the critical t-value is the same. So the only real difference is the formula for the two-sample t-test, which t-stat p-value equals stats.t-test IND, and then before treatment and after treatment, and then you print your t-statistic and your p-value. So your t-statistic is going to be 1.612, and your p-value is going to be 0.129. So your t-statistic is going, and then you have to interpret the results. So your t-statistic is less than the critical value, and because the t-statistic is less than the critical value, the null hypothesis is going to be accepted. And then the alpha, so the p-value is greater than the alpha, so the null hypothesis is going to be accepted as well. So you've got two instances of the t-statistic and the alpha, which are going to allow you to accept the null hypothesis. So you can see that we have used exactly the same data, but you get different readings depending upon which test you use. If you use a paired t-test, the null hypothesis is going to be rejected, which means that there is a significant difference between the after treatment and the before treatment. And then if you use the two-sample t-test, it's going to accept the null hypothesis, which means that there's no significant difference between after treatment and before treatment. So what that means is you have to choose your hypothesis test carefully and which one that you're going to use. So obviously I can't tell you what to do, so you can always try it, try it with the paired t-test, and then if it doesn't work, and then if you really want it to work, then try it with the two-sample t-test. But the only thing I can do is just tell you how to do the test and tell you to choose your test very, very carefully, because the test that you use is going to determine what your t-statistic and your p-value is, and your t-statistic and your p-value are going to determine whether or not um, the null hypothesis is going to be accepted or rejected. So I think I've covered everything that I need to cover in this video. I hope it was meaningful for you. If you like my video, please like and subscribe. Thank you so much for watching my video, and I'll be making more videos for you in the very near future soon.